Welcome back. In this video I want to show you how we can derive or how we can get the four trig functions or trig ratios just by using the first two basic ones. Okay, so guys, the basic ones are the sine and the cosine. So we know sine of a theta is opposite over adjacent, opposite over hypotenuse, and the cosine of theta is the adjacent over hypotenuse. So guys, from here, although in my previous video I have defined all of the six ratios, but guys, we can basically get all of these four different other ratios just by using these two. So guys, let us first look at the cosecant. So cosecant of theta is the reciprocal of sine. So what does that mean? That means the cosecant of theta can be written as 1 over sine of theta because it is the reciprocal of the sine. That is what that means. Or guys, we can also write sine theta as 1 over cosecant of theta. They both basically mean the same thing because they are both reciprocals of each other. So guys, from here, if I have to find or if I have to write the cosecant, it is 1 over sine. So it is 1 over sine, which is opposite over hypotenuse. And if I simplify this, it's just going to be hypotenuse over opposite. Okay, so this, now you have two ways of thinking about it, guys. First one is the very simple way. Sine is opposite over hypotenuse, cosecant is the reciprocal of it, so which automatically means that you have to just switch this, it's hypotenuse over opposite. Now this is like another way, like a mathematical way of kind of simplifying these things. And if we take the ratio of 1 over this, obviously we know that this will change into a multiplication. As soon as this changes to a multiplication, this will be reciprocated, so it is going to be 1 times h over o. 1 times h is just h, so it is hypotenuse over opposite. That is how we get the cosecant of theta from the sine theta. Guys, this is also identity, like one of the first basic identities that one has to keep in mind, because we will be using them as we start learning or as we start going into more advanced concepts. Okay, so keep this in mind when we think or when we talk in terms of the reciprocal. It is basically saying that this ratio cosecant is 1 over sine, or if you want to write the relationship between sine and cosecant, sine would be 1 over cosecant. Okay, similarly guys, if I have to figure out the secant, we know secant is reciprocal of cosine, so obviously similarly it's going to be 1 over cosine theta. Same thing here guys, cosine of theta would also be 1 over secant. They are both reciprocals of each other. Now if I have to figure out the secant theta from this formula, it's going to be 1 over the ratio cosine theta. I already know that cosine is a over h, and if I simplify this, it's going to be 1 times h over a, and that is h over a. That is hypotenuse over adjacent, and we knew that to get the secant, the reciprocal means you just have to flip the ratio. H comes upstairs and a goes downstairs, and that's the same thing you can see here from doing this. So guys, this is the other identity that one should remember, or one should try to basically, I mean, there's nothing really to remember. It's more like understanding, hey, these are reciprocals. What does that mean? That means it is one of them is 1 over the other one. Okay, the third one that we want to talk about is called the tangent. Guys, the tangent, we already know the definition for the tangent. It is the ratio of the opposite over adjacent, and that is one of the things that we should remember. And we know the short form, the SOHCAHTOA form of remembering it. That is totally fine, and we have to remember it like that. But guys, there are other ways of actually defining a tangent function. So tangent is, we already know that tangent is opposite over adjacent, right? Now let us do one thing. Let us guys take the ratio of sine over cosine, and let us see what we get. We're taking the ratio of the sine over cosine. So what does that mean? That means we are going to take the ratio of those right hand sides. So opposite over hypotenuse divided by adjacent over hypotenuse. If we simplify this, we know to simplify two ratios or to divide two ratios, what we do is we don't change anything with we don't do anything with the numerator, the ratio in the numerator. All we do is we change this to kind of a multiplication, and when we change this division into a multiplication, then this ratio is flipped. So what happens to this ratio? It becomes times h over a, right? That is how we simplify the ratio, dividing two ratios. Guys, if I simplify this further, obviously we can see that there's a hypotenuse upstairs and downstairs. Basically these are lengths, right? So this will cross out, right? It's a quantity divided by itself. It's going to just cross out, go away, and then finally I'm left with opposite over adjacent. Isn't that exactly what we already knew about the tangent function, that it is the ratio of the opposite over adjacent? But by doing this, we have kind of discovered a new identity. That is that the tangent of any angle theta is the ratio of the sine of the theta over the cosine of the theta. So that becomes my another identity, that the tangent is the sine over cosine. Yes, tangent is also opposite over adjacent when you think in terms of a right triangle. But in addition to that, tangent can also be defined as sine theta over the cosine theta. So guys, one has to know different ways of expressing each of these ratios, right? Similarly, if I have to write the cotangent of theta, guys, cotangent is the reciprocal of tangent. So cotangent, first of all, can be written as 1 over tangent. And if I have to write cotangent in terms of sine over cosine, obviously I can go back directly to here, and I know that the cotangent is the reciprocal of tangent. That means I will have to switch these around. So cosine becomes my numerator and sine becomes my denominator. So that would be the definition or a way of expressing the cotangent of any angle theta. So guys, this will already be on your trig textbooks. You will already find these identities, or if you already have printed out a formula sheet, I highly encourage that you should have a trig identity formula sheet in front of you when you are doing something or doing solving examples for the trig course. But guys, here now you already I kind of defined it, and now we kind of see why these things and how these things are connected to each other. So please take some notes on this, try to kind of practice this and see the relationships. If you are looking at this for the first time, you may have to spend some extra time to kind of see the relationship and remember some of the basic things. And then guys, once we understand or we define these basic things, then we are going to start actually using these ratios, these functions, and solve some examples. There's going to be many different types. Guys, I'm going to try to do as many types as we can here. After that, if you have any other questions, please feel free to reach out to me. I'll be more than happy to help you with any of your questions. Guys, till then, take care. I will see you next time.